Problem number 179. Graphing the cosine function y equals cosine x. And in order to do this, we are definitely going to have to get ourselves familiar with the unit circle once again. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And of course, cosine, comma, sine. Alphabetical order, it's that simple. Now, cosine 0 is therefore 1. Cosine 90 degrees is therefore 0. Cosine of 180 is negative 1. Cosine of 270 is 0. And cosine 2 pi is back to 1 again. So we end up with these main points. 0, 1. Now let's get our 4 points here. This would obviously be 180 degrees, which is pi. This would be 360, which is 2 pi. 90 degrees, which is pi over 2. And 270, which is 3 pi over 2. Now, here we go. The main points are these. Negative 1, pi, negative 1, 3 pi over 2, 0, and back to 2 pi, comma 1. Now, it's not a V. There's a curve to this. And the way we do this, and actually, and move this guy over just a little bit. Okay, now we need to take a look at the 30-degree angle, 45-degree angle, and 60-degree angle. Cosine of 30 is 0.866. Now this is 90 degrees, right? So therefore 45 is halfway, which means 30 and 60 are just a little bit away from those. So cosine 30 degrees is up close to 1. Alright, just a little bit less. Cosine 45 is 0.7. A little bit less than that. Then cosine 60 is halfway. So you end up with this kind of curved shape. And that's how, now remember, what is this? This is all quadrant 1. We've talked about this in other videos. Anything that happens here, and it just makes sense again, between 0 and 90 would be all things that happen in quadrant 1. Therefore, this is what happens in quadrant 2. So there's going to be a curve to that as well. And then, of course, quadrant 3. So that's going to curve back. And then quadrant 4 is going to curve this way. So you're going to have this, that's what causes the curve, is that cosine 60 ends up being halfway. Okay, so this would be cosine x. Next one. Cosine 2x. Now, in order to do this one, we're actually going to be changing our input values. You see, 2x. In order to get a 0 there, we can start with 0. We're still going to have 0, 1. Okay, but what is the, now the overall shape of cosine is still going to be kind of that swan or that fly shape, kind of that bird flying shape. And what's going to happen is the 2 is going to divide into all the x values. You see, the 2x is in the quote-unquote x position of our cosine. So all of our x's are going to get divided by 2. So instead of having 0, 1, it'll be 0 over 2, comma 1, which is still 0. But pi over 2 divided by 2 is now what? Pi over 4. Pi divided by 2 is, of course, pi over 2, comma negative 1. And 3 pi over 2 is now what? 3 pi over 4, comma 0. 2 pi divided by 2 is just pi. So therefore, we complete a cosine cycle, if you will, a swan-shaped cycle, before we even get to 180 degrees. So we're going to have, here's pi, here's 2 pi, pi over 2, which would obviously be 90, and 3 pi over 2 is 270. Now, what happens is we end up completing the swan shape at pi rather than at 2 pi. So it's not going to be spread out, it's going to be squeezed in now. So we're probably going to fit 2 of these guys in this period, as we would call it. So that's how that all works. So here we are, 0, 1. pi over 4 comma 0. Pi over 2 negative 1. That brings us down here. See that? 3 pi over 4 is going to be here. And then pi brings us here. So we're going to end up like this. Probably got to draw this a little bit nicer, but yeah. That's how it's all going to work. Because you're going to get that curve. Because again, because of this. Alright? And then what's going to happen? Same thing. We're going to go halfway between there. See that? So we end up with 2 complete cosine cycles within the 2 pi, probably because of the 2. If this would have been a 3, we would have completed 3 of them. Next one. What about if there's a 1/3 in front of there? Well, same thing. The 1/3 x would be in the quote-unquote x position. We're taking cosine of 1/3 x, which means all these x values would not get what? Divided by 2, but what? Multiplied by 3. So you'd still have 0, 1. Now you're going to have what? 3 pi over 2, comma 0. This is going to be what? 3 pi, comma negative 1. What's this one? 9 pi over 2, comma 0, and 6 pi, comma 1. So what would end up happening is the 1/3 would then take the what? The cosine, what do we call this here? Cycle, and stretch it out when the 2 in front of it squeezes it in. Alright? So we would end up with part of a cycle, and what we would probably want to do here is just call this 6 pi. We'll do a 3 pi here. We'll do a 3 pi over 2 here. That's halfway of that, yeah. And then, of course, 9 pi over 2. 1. By the way, what if there would have been a number in front of here? If like this would have been a 5 or something, we would call these 5s. Right? So, brings us down. Just like that. Alright, so there's a cosine there. So it basically took the original and stretched it out. Obviously, I didn't stretch it out too far from compared to the 2 pi, but yes, you guys see the idea, hopefully. Here's an interesting situation. Cosine pi x. This is pretty cool. Now, what you got here is what's in the x position. You have pi x in the quote-unquote x position. What are you going to divide all of these by? Instead of dividing them all by 2 like we did in this one, right? We divided all these x values by 2 here. Right? Did pi over 4 for that one, pi over 2, 3 pi over 4, and then pi. What are we going to do now? We're going to divide everything by pi. Isn't that beautiful? So all the pi's are going to be gone. That's what's cool about this one. So we're going to end up with 0, 1. We're going to end up with half, comma 0, 1, comma negative 1, 3 over 2, comma 0, and 2, comma 1. So we end up with all rational, in fact we end up with integers. So it's pretty neat, but yeah, we end up with the same overall shape, except we have 2, 1, half, 3 over 2. There isn't even a pi in there. And of course we're going from 1 to negative 1, so there it is. Next one. Uh-oh, pi over 4. Pi over 4 is going to be in front of x. Alright, now let's go through the logic. What did the 3 do when it was a denominator? It multiplied all of the x values by 3. Right? 3 pi, 9 pi over 2, and 6 pi. What did the pi do in the last example? It got rid of all the pi's. So if you have both, what's going to happen to our domain? Well, 0, 1, that's on all of them. All right, what about this one? It's going to get what? Multiplied by 4 and divided by pi. 0, what are you going to do? Times this by 4 gives you a 2, divide by pi gives you 2. That's it. Pretty neat. What about this one? 4, just 4. 4 comma negative 1. What about this one? All right, 3 over 2 times 4. 3 over 2 times 4 is 6 pi divided by pi, 6. Whew. And 2 pi times 4 divided by pi is 8. Isn't that awesome? It's pretty neat the way it all happens. Here's our 8, 4, 2, 6, 1, negative 1. So, right there. Alright, so that's the cosine function with a lot of different translations, as we did have different variables and values in front of that x. Good times. Any questions or concerns? Please send me an email. Good times.